Okay, let's just first briefly introduce the code and then we'll do the simulation. And the first one was the transaction generator. And for the transaction generator, so because we need to sometimes generate invalid transactions, so I'm use the random number, use the random RNG, use this to generate a number between 0 and 100, and it's got 2% to generate an invalid transaction. And then what's the valid transaction? First of all, we just need to read the states of the tip, which was the last block in the longest chain. And then we randomly pick up two accounts and then randomly pick one as the sender and the other as the receiver. And for every transaction, the value was 100. And then we make a transaction roll and then make a signed transaction. And if this transaction was verified by the current states, then we just add them to the memory pool and broadcast the new transaction hashes message. And that was the transaction generator. And then for the miner would also be the same, but this time we got to make the transaction meaningful. So for every time we just iterate over the memory pool and choose 3 transactions to fill the block. And if the transaction was not valid, we just add them to the delete list. And after we choose 3 transactions, we just remove every invalid or outdated transaction in memory pool. And that's the miner part. And for blockchain part, for every blockchain we add a block states, which just store the states. Let's just introduce the states first. And for the states was just because I realized account-based mode. So the states was just a hash map, which the first contains address and then contains the nonce and balance. And I also implement the display function for states, which would make it good to see on the terminal. And after that was the blockchain part. So for every time I initialize 5 users to the Genesis blockchain, to the Genesis block, and everyone got 100 multiply I money, and then for every new blocks, for every insert, after insert we should update the states, which means we will read the parent states and add new information in the receiving block, and then we update the block. And if the block, if it's valid, then we just need to add them into the block state. And then for the worker part, we added 3 new messages. The first message was the new transaction hashes. The second was the get transaction, and the first 2 was the same logic as the previous one. Also, I modified the message block because for every time you create a new block, you need to remove the transaction in the new block, which also in the memory pool. And for new transaction hashes, same logic as new block hashes. Get transaction, same logic as new block. And transactions, almost the same logic as blocks. So let's get to simulation. And first of all, let's run 3 server. After running them, as we can see, they have connected to each other. And then we will do the simulation, and we will occur the 3 things. As we can see, first of all, we just received some transaction. For briefly, I just print its hashes instead of the whole transaction. And then every time we will print the states of the current account. We'll see the count address and also the balance of each account. Okay, let's leave them to run for a few seconds. Also, when we get a new block, we print its trace. And also for the invalid transaction. So because we got 2% to generate invalid transaction, so if the transaction is invalid, it will print on the screen. I guess we can just shut them down. And then if I shut them down, then the total information would be shown on the terminal. And first of all was the for node 1 it mined 12 block, for node 2 it mined 12 block 2, and for node 3 it mined 12 block, and the total number of the block was 36. And as we can see, the longest chain, and the longest chain was the same for the 3 nodes. And also we can see the delay for every blocks, which is also consistent. And finally, we should look at the states to see whether our simulation is right or not. As we can see, for every user, and they got the same balance in each node. So our simulation was right. And also for the last point was sometimes you need to generate invalid transaction, and I have to do that too. So for every invalid transaction, so if the transaction the user didn't contain the accounts, then it's an invalid transaction. Or if it's not verified signature, then it's an invalid transaction. And I think I've met the 5 points in this assignment. And thank you.